Today we are going to talk about this question. Normally we get questions like this, right? We usually have a log here and log here, but not for this one, if you understand what I mean. And we usually get AS. So how do we do when we get a question that is GS instead of AS? So you know what GS is. That means there is a common ratio. Yes. And this is the question. This is from my past paper, my school past paper question. The last question, I believe. And this is the question, and these are the given information, and that is part A. I have found part A, and I have found that the first term of the GS is 243, and the general equation, the general formula, the general look would be this one. So the common ratio will be 1/3, and this is the and this is the first term, because normally the general formula should be like this. So this is the first term, common ratio, blah blah blah. Now what we're looking at will be part B. If we have log 9, remember there's a base 9, G1 times G2 times G3, the blah blah blah, to Gn is smaller than -100. Find the least possible value of n. So first of all, when we're looking at this question, first thing you have to know that it's okay, you won't die no matter what. Okay, so after getting that out of the way, we can quickly solve this problem. Another key information I'd like you to understand is that when you have a GS at first, and when it has become logged, for example GS1, GS2, log, this blah 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 plus blah 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 automatically becomes an AS sequence. So this is the same for this question. After being logged, it will automatically become an AS sequence. Why? So I'm going to use this as an example to show you about this information. First of all, we can just quickly copy this down. Base 9, remember about the 9, and then we can quickly just copy down the information. And then what we're gonna do is, of course, we know how to solve log, right? Like we know the basic log properties. So we know that when we have log A times B, it means log A plus log B. And when we see log A divided by B, we know that it means it's log A minus log B, right? These are the basic log properties. This is not a negative, okay, honey? This is just the basic log properties. Anyways, so we got this. That means that you can just quickly and then quickly, oops, I forgot the base. See, the base is very important. You will know later on, because that base nearly killed me when I was trying to finish this question. Anyways, yes, this is what we've got. Okay, so now we see this, okay? This is what we have expanded to become. And this, as I mentioned, is actually a secret AS. So I'll tell you right now how. So we know that G1 is like this, right? And G2, we know through this general formula, we know that it is 2 minus 1, so 1. And we know that this is a common ratio, right? Because why? It's because when you use G2 divided by G1, which is like this and this, we get the same, okay? So this, we get this ratio, okay? So when we get this log formula, say we're using these two examples, G1 and G2. When we get G2 minus G1, because we want to check whether it's an AS, okay, AS sequence. So we can use this to check, as I mentioned just now here, this information. This means that it's G2 divided by G1. This is actually a secret. It's a secret note. And you actually get the same, okay? Because this is just what's doing here. It's the same. What's happening here is the same as what's happening over here, because it's just G2 divided by G1. So we kind of ignored the log 9 first, and we get this, right? So then we can see, oh, this is the common difference. So you may ask, okay, so maybe it's just G2 and G1 just get this number. Look, how do you know that the other G's, for example, when G3 minus G2, when log 9 G3 minus log 9 G2 equals the same as this? Or what if, how do you know log 9 G5 minus log 9 G4 equals this as well? Honey, chill. We know this because this, no matter which thing you sub, as long as it is the later term and the previous term, so this is a number 4, we will always get the same ratio because it is a GS, right? So we will always get this number, and when we plug it in, we just get this common difference. So what we can tell from here is that this is the ratio of the GS sequence, and this whole thing, log 9 1/3, is the new common difference of this AS. So this is a key information that will lead to, like, you know, whether you can solve this problem successfully or not. So after talking about this ratio, okay, what now? We got this ratio, okay. What's the next step? So we know that we have a sum of AS. So it's either the first term plus the last term divided by 2, or it is this equation. So 2 times the first term, sorry, I'll just write it here, or this is the total number of terms that you want to plus together, that you want to like have a sum of. For example, you want to know the sum of the first 10 terms. This n will be 10. And then you just times it. 2 times the first term plus n, same as this one, minus 1 times the difference. Okay, we know this equation. This is just the sum of AS formula, and I usually use this because it comes in handy because I don't have to always find the last term. If you're using this, you have to find the last term, and for this equation you can't really find the last term because we don't know what the last term is. Okay, back to this question. Then we got this, right? We got the common difference. And actually, we have the first term too. the first term, you can see it's here. This is the first term. Hey! So this is the first term. Don't you forget that this whole thing is the first term. When I was doing this question, I forgot about the log 9 and I just used G1 as the first term, but that's wrong because right now in this new AS form equation, the first term is log 9 G1. So what we're gonna do is pretty easy. We're just gonna like do this. Just copy down the formula, but not exactly. We're just gonna substitute some numbers in it, which you will know later on. So this is the first term, as I mentioned, and we all know that G1 is 2, 4, 3, right? I just mentioned it at the beginning of the video. And because n we don't know, we are trying to find n, so n will remain as unknown. It's fine, it's totally okay, because we are looking for n. And then what is d? What is the common difference? What did we learn just now? This is the common difference. So we get this like this, and it's a pretty little equation. And quickly we can just solve this equation 2 times, and then this is a negative, just so we see it clearly. This is a negative, and then we can just quickly use my calculator and calculate the first term. So in case you forgot how to press it, it should be this. This is the base, and then this 2, 4, 3, so it's 2.5. So times 2 equals 5. So n, right, and then n, minus 1, and then we can quickly press the common difference, which would be 9 over this thing. Yep. Okay, so times negative 0.5, and this is very fun because this is getting simpler. You see, it looks very neat and tidy. Oh, not my handwriting, but whatever. You get the point, and then you times n into the brackets, okay? So before you do that, actually, I'm just so silly, aren't I? Is that you times it into, so 0.5 is like this, and then like, okay, and then we times it into the brackets, 0.5n minus 0.5n2. So this is what we get, and then we later on gonna press this calculator, but the thing is we need to remove this negative. We can't have a negative in our quadrilateral equation. Okay, so what we're gonna do is we're gonna bring it here, just really step by step, because I usually don't write this. And then, okay, so 5.5n, okay, and then we can use this whole equation divided by -1. And when we do this, we have to change the sign. It's just really important thing, and the whole thing will change its sign, and then we can quickly press formula 1. Okay, and then we get this and also this. We have 2 answers. So how do we do this? We remember that it's above, it's larger than 0, and this is a plus, so it's plus. So it's opening upwards and it's larger than 0, so it's here. That means that there's or. This means or. If it's at the bottom, it means and. If it's connected, it means and. If it's separate, it means or. So n is larger than the larger answer, which is 26.2, and or n is smaller than the smaller answer, which is -15.2. So this is the correct answer. I can assure you because I checked the marking scheme, and this is how you do this silly little thing. And I'm gonna talk about the other question, which uses the same or similar technique. And I also am going to talk about this question, which is easier. This is a lot easier. I have been thinking and drilling on this part for like the whole day. I cannot do this anymore. Okay, goodbye.